Okay. Last year, Bjarne Stroustrup, the creator of the C++ programming language, visited computer laboratory here in Cambridge, and he gave a talk titled C++ as a modern programming language. He was trying to answer a question: why is C++ still a relevant language in modern industry? He spent about an hour talking about all the cool features that C++ is going to have in a few years. So he obviously failed to answer the question that he posed himself, thus making that question something that causes people sleepless nights, like other questions. For example, is P equal to NP? Is John really an alien lizard? Or who let the dogs out? So the same Bjarne Stroustrup once said in defense of that abomination of a language, there are only two kinds of languages: the ones people complain about and the ones nobody uses. So today we're going to complain about the languages that people use. It's not supposed to be 100% serious talk, so the alternative title is this. Sorry, not going to be doing that again. OK, without further ado, let's talk about Java. We're going to start with something mild, something easy. What will this line of code print out? Any guesses? Who thinks it's going to be 2 plus 2 equals 4? Who thinks it's going to be something else? It's going to be 2 plus 2 equals 22. Don't be ashamed if you got it wrong. Wait, 1A's already finished Java. Yeah, you should be ashamed if you got it wrong. What happens here, the plus operator in Java actually represents string concatenation and number addition, but it's exactly the same operator in both cases, so there's no precedence of one over the other. And the plus operator is also right associative. So what happens is we first have 2 plus 2 equals, that string, concatenated with a 2, which gives us 2 plus 2 equals 2, and then another 2 concatenated to the result of that, giving us this string. OK, but whoever wrote this line of code probably intended for this to print out 2 plus 2 equals 22, because I've written that line of code for this specific purpose. But if you ever saw that line anywhere else, probably the intent was to print out 2 plus 2 equals 4. How do we make this line print that instead? Brackets around 2 plus 2, yes, that's one solution. Or whatever any sensible person would do, just use printf. Yes, Java does have printf. So this line of code is rock solid. There is no way this can print out anything else than 2 plus 2 equals 4. Even if I put some weird function call on top of it, like set 4 to 5, yeah, it would be stupid. There is no such function in Java, and you can't implement it. Oh. OK, before I explain what happens here, let's have a short digression. As you probably all heard, everything in Java is an object, except for primitives. Well, unless we want those primitives to be objects, then we can make them objects. Java introduced those wrapper classes like integer, capital I integer. But creating those objects around the primitives, that's called boxing, is expensive. So what we have is a cache of integers. So we don't have to create a new instance every time. We just reuse an old one. And to make it even faster, that cache is pre-populated with small integers, namely from minus 128 to 127. The best part of it, not only we can access that cache, we can modify it. So this is exactly what that function does. First, 4 lines access the cache, and then the last one reassigns the 132nd value, because, you know, minus 128, which represents a 4, reassigns it to the 133rd value, which represents a 5. And this will actually print out 2 plus 2 equals 5. When I first heard that, I was like, no, that's not true. Let me try it. So here we have the exact same code. As you can see, the set 4 to 5 line is commented out. So if I compile and run this, I get 2 plus 2 equals 4. That's fine. If I uncomment this, and I run it again, 2 plus 2 equals 5. Conveniently, Java also has an inbuilt function for shuffling an array of integers, or any array. So we can do this. Obviously, minus 104. What? OK, what does this print out? Who thinks it's hello world? There are a few people. Who thinks it prints out something else? Well, you're wrong anyway. It prints out nothing. In fact, it actually doesn't compile. Let me show you. Exact same code. Compile it. Error. Illegal Unicode escape. What? We didn't have any Unicode escapes. Actually, we did, because they start with \u, and the third line, a comment, had a \u in the path, as you can actually see in here. And then after \u, for it to be a legal escape, we would need a hexadecimal number. But S cannot be a part of hexadecimal number, so this fails. The problem with this is that all the Unicode escapes in the code in Java are replaced by appropriate characters before any compilation is done, so before even the comments are stripped out. And this way, if we have a Unicode escape somewhere in code, it's going to go wrong, even if we didn't intend it. OK, that's enough about Java. Let's talk a bit about C. So again, same question. What will this print out? Who says it's 3,000? You're not going to be very, I'm going to be careful now, won't you? OK, let's try it. Exactly the same code. Let me run this. 3,000. Ta-da! But that's on Windows. Let's try the exact same code on a Linux machine. Here I have a Linux machine running on a Linux system running on a virtual machine. And I have the exact same code running, the exact same code in the file. Let me try compiling it. Whoop, no.c. Doesn't compile. Why is that? It's because C has this hidden thing where on Unix-based systems, while preprocessing, all the instances of the word Unix are going to be replaced with a 1. That means if I have a variable starting, which name starts with Unix, I'm going to have a number in front, and that's not going to work because that's illegal. I can actually show you Unix C, Unix prep C. It actually does. After preprocessing, Unix is replaced with the number 1. OK, that's not what I want. What will this do? So as you can see, this is a main, but not a function, an array. Array of integers. You may have already guessed that this is machine code in the form of integers. And for those of you who can't immediately read machine code in this form, I actually have a demo as well. Exact same code here. if I compile it, it will even give me a warning that main is usually a function, but it's going to compile just fine. And when I run it, it prints out hello world. However, to be fair, none of those two things are part of the C standard. So let's talk about something that is part of the C standard. Which ones of you know what the rand function does? R, A, and D, in case I wasn't clear enough. Who knows what it does? No, like, seriously, what does the function do? It gives you a random integer. Whoa, I had a joke here, I forgot about it. Too bad. So the rand function is defined by the language specification to compute a sequence of pseudo-random integers in the range from 0 to rand max, where rand max is a constant defined to be at least 32,767. What's the problem with this definition? Well, it guarantees literally nothing, apart from the fact that the number it returns is between 0 and rand max. The sequence can be biased towards even numbers. That's fine. It doesn't even have to be a uniform distribution. It can be exponential. In fact, it doesn't even have to be able to return all the values. If all it did was always return 9, according to the specification, everything's fine. So yes, if you have seen this XKCD, according to the C language specification, this is a perfectly fine implementation of a rand function. OK, enough about C. Let's talk a bit about JavaScript. So a quick quickie first. What's none? What does this stand for? Not a number, yes. That's a special not a number value. What's type of this not a number value? Number. One job, JavaScript. One job. OK. Let's talk about equality. In JavaScript, we have two equality operators, double equals and triple equals. Triple equals is actually an identity operator. So it only returns true if both values are literally identical. Double equals does some crazy stuff. So for example, an array containing a 0 and just the number 0, according to JavaScript, are equal. Why not? Similarly, the number 0 and an empty array are equal as well. So if those two hold, that means an array containing a 0 and an empty array should be equal. But they're not. Obviously, they're not. In case you didn't believe me, here we have code that checks exactly that. Notice the use of brackets. There is no printf in JavaScript. It's not a sensible language. Let's run this. As you can see, it's exactly what I told you. Array with 0 equals 0. 0 equals empty array. But array with 0 does not equal empty array. There are two extra examples on the bottom. An array containing 2, 3, and 5 does not equal another array with the same values, 2, 3, and 5. But if we compare it to a string, 2, 3, 5, yep, that's fine. That's equal. So the double equals, like I said, it's kind of crazy. Here's a diagram which shows you which basic values are equal to which ones. I do realize it's difficult to read anything in here. But in the top right-hand side corner, we have an array containing an empty array, which is equal to false. And this actually stacks indefinitely. An empty array is equal to false. Array containing an empty array is false. Array containing an empty array containing array containing an array containing an empty array is also false, and so on. But as soon as we put false inside an array, that's no longer false. OK, a bit about addition. I hate this slide. I very much hate this slide. I changed it 4 times, and it's still not technically true. That's because all this depends on implementation, because guess what? Specification is ambiguous. So what does empty array plus an empty array return? What do you think it would return? No. Empty string. Empty array plus an empty object. Curly braces are an empty object. That's this string. And if plus is commutative, so if I exchange the operands, it should return the same thing, right? Yep. And now two empty objects, that one actually makes sense. It's not a number. OK, what happens here? First of all, the binary operator plus in JavaScript can only represent 2 things: number addition and string concatenation. Type error is not an option. List concatenation is not an option. It's going to be either one of those 2. It's going to be string concatenation if any of the operands wants to be treated as a string, which an array would be. Otherwise, it's going to do number addition. So the object, for example, doesn't want to be treated as a number. So if we have 2 objects, they will be treated as numbers. So let's go back to those examples. And now, actually, the first 2 make sense, because we have an empty array which wants to be treated as a string. So we cast it to a string that gives us an empty string. We concatenate it with whatever is the other operand, and we get the other operand, because an object casted to a string will give this object-object thing. The last one also makes sense, because both the first and the second operand want to be treated as a number. So we cast them to a number. That gives us none. Some of those is a none. But what about the third one? It's an empty object plus an empty array. It's not number addition, because empty object should give us a none, so the entire result would be none. It's not string concatenation, because, well, the result is not a string. So what is it? Well, this plus is actually not a binary plus. It's a unary plus. Because in this case, this pair of empty curly braces is actually an empty anonymous code block. There is no semicolon required afterwards, just like we don't have to put one after an if statement. And then we have another expression, plus empty array, which is a unary plus, which basically converts the value to a number. An empty array converted to a number is a 0, obviously. So it actually does make sense. However, it's not that easy. If I run Node, which is an implementation of JavaScript, and I actually run this in Chrome, that would give me a none. Here, it gives me this. This is not a unary plus, and this is not number addition. If I try to add anything else, it's actually going to be treated as a unary plus, because ABC, the string converted to a number, gives us a none. Same if I do this. I try to understand why. I failed. OK. So that's enough about JavaScript. Time for the grand finale, my favorite programming language, PHP. To tell you everything that's wrong with PHP would take about 2 talks. I should have done that. But just to give you a short introduction, I'm going to show you with some quotes from the creator of PHP what kind of language we're dealing with here. So Rasmus Lerdorf, the creator of PHP, once said, "I am not a real programmer. I throw together things until it works, and then I move on." Real programmers will say, "Yeah, it works, but you're leaking memory everywhere. Perhaps we should fix that." I'll just restart Apache every 10 requests. He also said, there are people who actually like programming. I don't understand why they like programming. Well, if they're using PHP, neither do I. OK, but that's kind of unfair. That's quote mining, plus Rasmus Lerdorf is not really working on PHP anymore. Let's have some quotes from PHP itself. Here we have an actual error message that PHP returns if you do something wrong. Syntax error, unexpected t pamaim nekudotaim. Ha. So this is a name of a token. The t prefix tells us that. But what's the rest of it? It's Hebrew for double colon. I mean, OK, it sounds stupid, but if all the tokens are named in Hebrew, I can kind of understand it. It's more of an internal thing, and the company responsible for PHP is located in Israel. So if all the tokens are named in Hebrew, they're not. Just this one. And it even has an alternative name, T double colon. So developers using PHP did complain, and they complained a lot. So this error message was changed to this. OK, we talked about equality in JavaScript. Let's talk about equality in PHP. So we have two values, an array containing 0 and false, and another array containing an empty string and an empty array. Do you think they are equal? Yes, they are equal, because double equals does some crazy conversion between values, and it actually doesn't bother with doing reference checking for arrays like JavaScript does. It checks all the values. And 0, false, empty string, and empty array are all equal to each other. Now those two, string containing 0e123 and 0e456. Equal or not? Obviously equal. If they weren't, it wouldn't be worth of this talk. Why are they equal? Because they are converted to numbers before the equality is checked. And both those strings actually have a scientific notation in them that evaluates to 0 in both cases. So both those strings evaluate to 0 as integers, so they are equal, obviously. Why is this problematic? Because password hashes can start with 0e. And then all of them would be equal. Why not? Last example, are those two things equal? In case you don't notice, it's the last character they differ by. It's 3 versus 4. Actually, this depends. In newer versions of PHP, no, they are not equal. Surprise. In older versions of PHP, like 5.3, which is the most popular version used today, not supported for 5 years now, they are actually considered equal because they are, again, converted to numbers. This is too big for an integer, so this is going to be converted to a floating point, which is not precise enough to represent the difference in this last digit. So they are going to be equal. One last thing. What will this piece of code do? Or maybe let's start with a question, what should it do if we written it in any sensible programming language? In Java, it would fail because we can't post-increment a string. In C, actually, this would work and print out all the letters from A to Z because those are actually characters in this notation in C. So it will increment it up to Z, then above Z, that's going to go out of range. We stop there. What will PHP do is something that I won't explain it. I'm just going to show it to you. PHP is going to do this. So it starts with printing out all the letters from A to Z, But then it goes on. It doesn't stop there. It prints out almost all the pairs of letters up until, you can't see it because it's cropped, YZ. Believe me that YZ is the last one. Now, why is that? Because in PHP, string incrementation is a thing, as the title says. So if we increment A, that's going to give us a string with B. Incrementing that gives us C, and so on. When we hit Z, incrementing that gives us AA. But then, when we compare it with less than or equal, that does a lexicographic check. So AA is actually less than Z. So we continue until we hit AZ. Incrementing that gives us BA, and so on, up until YZ. Then incrementing YZ gives us ZA, which is already not less than or equal to Z, so it stops. Magic. OK, there are actually some serious conclusions I have from this talk, believe me or not. Let me remind you of the quote we started with. There are only two kinds of languages, the ones people complain about and the ones nobody uses. And this is true. This is very true, and not because we tend to use languages that suck, although we do. It's because all languages suck. There is no such thing as a perfect language. So it's relevant if you want to design a language, because designing one takes a lot of decisions to make. Many of them will be just personal choice, like whether you want Python-style indentation or curly braces blocks. But many of them will be actual trade-offs that you make that make your language good for one purpose, but completely terrible for anything else. And then when people actually use the language, they will criticize you for making those trade-offs because they want to use your language for something else. PHP originally was not meant to be used for big websites. It wasn't even used to be meant for it wasn't even meant to be used for websites. Sorry. It was meant as a simple text parsing tool. But then it grew, and it was terrible for the purpose it's used for. But what's more relevant for all of you here, because you're all going to be programmers, learning a new language involves learning all of those weird things about languages as well. Well, except for Malavik. So you will have to learn all those weird things. I only scratched the surface in this talk. There are many weird things in basically all of the major programming languages. And you're going to have to learn them. Not in 5 years, not in 10 years. You're going to have to start learning them as soon as you start writing real code. So probably very soon, if you haven't already. That is all I have for you today. Thank you very much.